technologies don't have to move from room to room trying to troubleshoot. They can troubleshoot from that central location. So that is what is called a center. So a data center contains physical and virtual resources. So the physical is the infrastructure where computing stroke networking systems and equipment, hardware systems and operating systems are placed. So this is the physical hardware. Then the virtualization layer, which abstracts and controls resources and usually composed of operation and management tools on the virtualization platform. The virtualization platform outlines the physical computing and network IT resources into virtualized components, and it makes it easier to operate, allocate, release, monitor, and control resources. What I was telling you, that the technologies has a console. Basically, a console is a screen and a keyboard where he can remotely access. When you call in and you need a service, he can remotely access your computer and he can configure it for you. He can install new hardware and so on. So I've said, I've given you the advantages of the data center technology. So the data center is based on standardized commercial hardware designed with a modular architecture. Why modular? Modular because you want the ability to add or the ability to remove hardware and the software. So they are not tied together. So modularity helps in addition of all the components in a networking environment. So the data center integrates multiple identical infrastructure modules and equipment with features such as scalability. Scalability simply means you can, as the number of people increases, you can add the hardware. If your institution has a policy of storing it, you have a storage server, then you can increase the memory on your server, or you can buy another server and link it to the existing servers. Substitutability, where you can change something. For example, you hear that there's a new switch which has come, which is faster. So the existing lower speed switch and replace it to the higher speed switch. And you should do this seamlessly. In other words, you will not interrupt services. And this is why we are talking about identical infrastructure, modules, and equipment. In other words, there must be some standardization, some standards that you will follow, so that when you remove one physical hardware and replace it with another, the disruption will be minimal. And I'm sure you must have heard of something called backward compatibility in computer networks. Now, in computer networks, every time a new technology comes, you usually make it backward compatible so that it can do what the previous hardware was doing, but it comes with its own new improvement. Let's say replacing a switch that was operating at 10 megabytes per second with a switch that is now operating at 100 megabits per second. Now you'll find that when you buy that switch, that new switch that is operating at 100 megabits per second, most of the time they will rate 10 stroke 100 megabits per second, meaning that this switch can replace the 10 megabits per second switch. What you'll just do is to plug and play. You just remove that 10 megabits per second switch and replace it with the 100 megabits per second switch. So what will happen is that if a device operates at 10 megabits per second, it still works. If a device needs 100 megabits per second, it's still working. So it becomes backward compatible. And in networking, most times new technology works like that. It's backward compatible. So what you will do is that once you have replaced all your links to be 100 megabits per second, then the next time you buy a switch, you can now buy a switch that is 100 stroke 1000 megabits per second. So under data center the technology, modularity and standardization are critical conditions for reducing investment and operating costs because they can achieve economies of scale. So remember, modularity, I said, you have different components working together. You can remove one component and replace it with another. You can add components and so on. Now, this is possible because of standardization. So these two achieve what is called economies of scale in procurement. It makes it cheaper for you. It makes it easier to do deployments, to put in new devices. It makes it easier for operation because you are using standards, and it makes it easier for maintenance because even when you are maintaining, you are following certain standards. So common virtualization standards and ever-improving capacity and performance of physical devices have promoted IT resources where we have fewer physical components supporting more complex configurations. For example, probably you have seen it. You have software that runs on Linux. Like networks, a lot of network simulation software runs on Linux. But here your machine is operating in using the Microsoft operating system. Now, the issue is, do you buy another computer so that you can run your simulations? And probably that's the only time you want to run the simulation. Now, that does not look feasible, because even buying that laptop, you struggle to buy it. Now, how come you are now being told you are researching into a certain area that requires you to simulate the internet, and you are being told that that simulator can only run on the Linux environment? Now, through virtualization, your machine is running Microsoft, but you can load Linux. And I've seen that happening. Your machine, when you buy it, it is Microsoft, but you can load Linux onto it. So it's as if your machine, you have two machines, and you have a Microsoft machine. But physically, it's only one device. So this is what we are saying, we are calling common virtualization strategies. So integrated IT resources, or rather, this is what I mean by saying fewer physical components can support more complex configuration. Just what I've said. Physically, you have a machine. When you bought it, it was Microsoft. You want to do simulation. The simulator that you are doing needs a Linux. So you load Linux on top of the Microsoft. And you are only able to do that through virtualization. So now you can run your simulation without necessarily buying a new machine. So integrated IT resources can serve different systems and can also be shared by other cloud users. So data centers have certain characteristics. Now, one of the characteristics is automation, where automation refers to a unique platform that can automate tasks such as provisioning. Provisioning is providing or adding new services, configuration, patching, patching in cases where there's a shortcoming in software. You can modify that software or you can add a component, and monitoring without manual or operations. So that the data centers should allow automation. Data centers should allow remote operation and management, where IT resources operation and management tasks are completed through the network, remote console, and management system. What I was saying, a technologist is sitting in his office, but he's doing things in another office that is 20 kilometers away without necessarily having to go there. So technicians do not need to enter the dedicated room where the server is placed unless performing equipment handling, wiring, or hardware level installation and maintenance tasks. So we have operation and we have some software that can help you to do this through remote console and management systems. And then high availability. To maintain high availability, data centers have adopted increasingly high redundancy designs. Redundancy designs is you are buying either extra equipment or you are creating extra links so that if one link fails, the other link comes into operation. Now, of course, for you to include redundancy, you are going to spend a bit more. Like the UPS. Under ordinary circumstances, the UPS is not being used, or even the solar. Supposing you have both the live or the hydroelectric power or the main electricity, but you have a solar system in place, or you have a UPS system in place, or you have the two of them in place. Of course, you'll use extra money to buy that solar system. You'll use extra money to buy the UPS, and you'll find that in normal operations, the two are not being used. You are using mains supply. So we say the two are redundant. So they'll only kick into play when the mains fail. Like these days, the mains are always failing. So you'll find that your institution continues operating even though there's a power blackout. So, examples, cope with the system failures, data centers usually have redundant uninterrupted power supplies, UPS, integrated wiring and environmental control subsystem for load balancing, and redundant communication links and cluster hardware. So to improve efficiency, then you usually introduce redundancy into data centers, because a data center is serving many people to do many things. So you must ensure that you do not have failure in the data center. Or you don't want, when there's a power, the whole institution is immobilized because of the power failure. Okay, any questions? Okay, so next one is the virtualization technology. I talked about it briefly, even talked about it last week. So the many definitions of cloud computing. Cloud computing, I tell you, that the definition, uh, you are better off describing it using a framework the way we described it using the NIST definition, the National Institute of Science and Technology, that American institute. It had its own definition. But remember, we took that definition and we put it into a diagram. So cloud computing can be defined as, or a cloud can be defined as accessible through the network, accessible on demand, subscription paid, shared by others, packaged also outside of your own data center, simple, easy to use, virtualized IT resources. So you can see we are talking, but the term virtualization comes under cloud computing. So this means, since it appears in the definition, it means that virtualization is an integral part of cloud computing. So this definition is not comprehensive, but points out that virtualization technology is essential for cloud computing. Now, what is virtualization? Virtualization is a logical representation of resources, and physical limitations do not restrict it. Like we have said, a computer is made up of a processor, it's made up of memory, it's made up of the bus or the links, and then the input and output devices. These devices, we could consider them resources. Now, these resources cannot work by themselves. So we have to introduce some intelligence. Now, that intelligence that we introduce is the operating system, which makes efficient use of these resources. But like I said, most times we use only a small percentage of the resources. Like, for example, when you are doing your assignment, you are typing. Typing does not need a lot of compute power. So at that time, you're only using 5%, maybe 5% of your resources. Now, you may want to do something else. Now, for example, what I was saying, you may want to do simulation, but that simulation software cannot run on your Microsoft operating system. And you see, if something like typing is taking 5%, 95% is idle. Simulation, 15%. So what you do, you'll want to use the same hardware for different tasks. You want to do it when you're typing your assignment. You want when you are doing your simulation experiments. So what you do, you load a different operating systems like Linux, and your simulator can run now on top of Linux. So why we are saying it's a logical representation of resources is physically it's one PC or it's one laptop. But logically, it appears to you like you have two physical systems, because one you're using Microsoft and another one you're using Linux. So it's virtualization which enables you to do this. So this virtualization enables you, or makes you feel as if you have two different machines, and yet it is one machine. And that is why we are saying it is a logical representation of resources, and physical limitations do not restrict it. Physical limitations is most times you are only using a percentage of your computer. So you will not feel it. When you start simulating, you'll not feel as if your computer is running slower, because you have not yet reached its limit. And we are talking about logical representation, because most of the time virtualization is done in software. So virtualization technology is not new, but these days you hear that term so much because of cloud computing. In early days, so because we are saying virtualization is not new, in early days, virtualization was implemented to make a single computer look like multiple computers. What I've just said, it's physically, it's a single machine, but it appears like two machines. One is running Microsoft and the other one is running Linux, or Microsoft and Apple. So completely, the technology was implemented to make a single computer look like completely different computers, thereby improving resource utilization and reducing IT costs. Improving resource utilization because now you are going to use your computer to its maximum capacity, and two, you don't have to buy new hardware. You can steal the existing hardware. With its development, the scope and concept of virtualization is also increasing. So computer systems are usually divided into several levels from top to bottom. Now, remember, initially, virtualization was just applied to computers, machines. But when when cloud computing was introduced, cloud computing has many things. It has hardware resources, it has different operating systems, it has different user software. Because a cloud connects people. Now, this many people will have hardware resources, different operating systems, different user software, so on. So what virtualization now can be done at the different levels. It can be done at the hardware level, operating system, user software level. So what is virtualization technology? Virtualization technology abstracts various underlying resources to form different virtual layers with the same or similar function as the real layers. Abstracting means hiding details from you. Now, I still go back to the example I gave about one physical computer appearing to run two different operating systems. So, as a user, the moment you decide that I want to use the Linux operating system, you'll just click on an icon and it gives you the interface of the Linux operating system. And you work as if